Hello, 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 bachcho. Am I visible and audible? Let me also check once. Okay, I am. Okay, great. Hello, everyone. Hello, everyone. Welcome to Deeksha Vedantu CBSE English channel. I'm your Aditi Ma'am, and we are here to continue our life, the previous one, the first chapter of class 9th science, that is entering the world of secondary science. How are you all doing, bacha? How are you all doing? I'm so excited for this live, right? This new book has me on I'm on cloud 9 looking at this book, and it's pretty good. I love it by far. But we are going to see this chapter, and we are going to see the NCERT solutions of this chapter, right? We studied a lot about this book. We saw there are so many videos where I have given you the strategy as well. The first chapter, the one shot, is already uploaded, and very soon the first chapter, the cell, will also be uploaded. Okay, do not worry. So subscribe this channel right now. Okay, now a very important thing today we are going to do, bacha, is to do the NCERT solutions. Now, ma'am, this chapter literally is just an introduction to how to explore science, right? What kind of NCERT questions do the board or your school teachers can give? See, to be very honest, I also don't know, right? So we'll just do everything that is there. Okay, there are lots of thinking questions there are lots of things, there are lots of scientists that we can study about, and that they can ask about. It totally depends on your school teacher. Okay, so that's basically what we are going to do today, right? Give me a thumbs up so that we can start the live session, bacha. Very, very fast. Make it fast. Okay, great. Okay, let's start the chapter. So earlier we did what we studied. We just studied what we are going to do in this class 9th, how science works, what are the questions, how scientists think, why do we study science, right? And the very important question is, science just facts or there is more to it, right? So we are going to cover all of that today, and we started with model. Now what's a model? Just a simplified version of this complex reality. Like my screenshot is a simplified version of my character, right? Maybe I am an overthinker, maybe I speak too much, maybe I do too much, right? But that won't be visible in my screenshot, in my photo, right? So my photo is just a simplified version of a complex Aditi ma'am. Okay, so similarly, globe is a simplified version of earth, sphere or dot is a simplified version of atom, that means model of atom. Diagrams, the diagram of heart is a simplified version of heart, because in that diagram we are not showing small chotu cells, tissues, even the whole heart we are just showing, right? So that diagram of heart is just a simplified version of the complex heart that we have in our body, right? So that is the basic thing. Now moving on, we studied how scientists think, what actually made Newton think that why the apple is falling downwards, right? Why is it not going upwards? So the very first fundamental thing of science, of studying science, is asking questions, right? And with that, moving a step ahead, asking right questions is equally important, my friend, right? Give me a thumbs up if you agree to that, right? Give me a heart. There is a heart, so you can press that heart as well. Asking right questions is very important, and you will not know what the question is right if that question is wrong, right? You will know by asking it. So ask wrong questions, ask filthy questions, bad questions, doesn't matter, but with a good intention. That's all we care about, right? Okay, next we have test. Now when Newton saw an apple fall, he started testing. He's like, pen is also falling, right? Pen is also falling. Although Aditi ma'am's catch is not good, but pen is falling. When we jump, we come down, so we also come down towards the earth. We do not fly away into the sky, right? So that's, he started testing, and he came to a conclusion that there is gravity, right? And then Einstein ji came and he was like, gravity is not there, it's just a space-time fabric. If you know, you know, right? Space-time fabric. So all that thing happened, and then we moved on and we questioned ourselves, and we started questioning, and we started learning how to actually ask right kind of questions. If there is a batsman, he hits a six. Will it be a six actually? Will it be a catch out? What kind of questions will you ask? Will you ask the color of the bat? No, right? You won't ask the color of the bat. You will definitely ask the mass of the bat. You will definitely ask the size of the ball, the weight of the ball, right? So those are the two categories where we ask wrong questions and where we ask right questions, right? So then we moved on and we studied about how science has its own language, a very, very beautiful language, okay? I will punch you with my full force. What does that force means? Like in this, it basically means it's my strength, it's my capability of hit. If I'm a boxer, then I can hit you with a bigger force. But in physics, in science, force has a completely different language. The work, what do I do? Ma'am, when I sit and I work, that's work. Yeah, that's work. But science has a completely different definition of work. Energy, ma'am, I eat food and that's energy. That's one form of it. But science has some different kinds of energies, kinetic energies, potential energies, and we incorporate that whole thing we understand with the help of science, because it helps us develop relationships between velocity, distance, time, right? How do we develop a relationship between them? Using mathematics, correct? Understood? All of you getting the point? Everyone? You're getting the point? Give me a thumbs up, give me a heart, so we can start the next thing, because last time we just did a very simple thing. Till here we understood, right? And after that we understood the units. There are some very important units. What are those, ma'am? Starting with the length, right? We studied about the case, right, where the plane was flying, and instead of putting 15,000 kgs of fuel, they put 15,000 pounds of fuel, and it was a whole massive blunder, right? The fuel was going out and the aircraft was in the space, I was going to say, in the sky, right? So we have to know what are units. Units are just what defines a quantity. If I say 5 meter, that's length. If I say 5 kg, that's mass. If I say 5 second, that's time. If I say 5 ampere, that's current. So all these have different meanings. If I just write 5, 5, 5, 5, 5, will you be able to distinguish what is time, what is current, what is length, what is mass? You won't be, right? So moving on, going a little bit deeper into that, we introduced SI units. That means if I say 5 kg, then 5 kg is same weight in India as well as in Ukraine or Germany, right? So all over the globe, the weight of 5 kg is same. And similarly, the 5 meter length is same. 15,000 kg of fuel is same, but we need to distinguish them, right? So these are SI units. What are SI units, friend? SI units are, these are the standard international units that are applicable all over the globe. So for length we have meters, for mass we have kilograms, for time we have seconds, correct? For electric current we have ampere. How many of you knew ampere? It's a little bit new. In 10th class, na, you will study electricity as well. And it's a very lovely chapter. It's a little bit big, little bit numericals are there. But we will do everything here, okay? And so if someone 10th class students are there, do not worry, we'll do all the stuff here, okay? Then temperature we measure in Kelvin. Then amount of substance, this is a chemistry term actually, but later in physics we also use it on graduation, post-graduation level, right? So mole, M-O-L is the symbol here, and luminous intensity is candela, C-D. This candela, I have not used it till date, it's my master's, but we still have to remember what exactly is it, right? Okay, let's moving on. The next we have laws, theories and principles. We studied laws is something that is true everywhere, right? Literally everywhere on the globe, in the space, in a million thousands of kilometers away in the galaxy, we have laws that also hold true. Although we do have some conditions, sorry, we do have some conditions for laws, right? Because when we see that there are laws, those laws should be applicable there, everywhere. But we sometimes define that it's not applicable in the space on the moon. It's only applicable on Earth, where we have controlled temperature and pressure conditions. So all those things matter as well, but then we define it. Okay, this is true, but temperature and pressure should be same. For all the people who have studied Ohm's law, we know that V equals to IR, but only when temperature and pressure conditions are same, right? Similarly, that is what laws are. Okay, bacha? Okay, so similarly, Newton's laws of motions are, we are driving and we use 3 equations of motion. You must have studied in the motion chapter, correct? But those are applicable only when what? Only when acceleration is constant. It will definitely ask, you know, when I was like giving interviews for teaching, they even asked me then that these are the equations, they will be used only when what? Only when acceleration is constant. Okay, bacha? Now, we have some theories. Now, I say that the nucleus is inside the atom, but then I'll explain everything. There are electrons, protons, their mass, their charge, and the nucleus does this. Why? How do I came to this conclusion that there is a nucleus inside the atom? So, there is a big experiment about that, right? Rutherford experiment, scattering experiment. It's very interesting. Okay, so those are theories. Okay, they define how and why the things around us that this is happening. Okay, so these are theories. That atomic theory explain why molecules are formed. So they tell you everything, how atoms are joined, why they are joined, why the orbitals are overlapping and all that stuff. Then we move on to principles. Principle basically is just a general rule, right? It's an idea that helps us to say that, okay, this student does not cheat. It's my principle that I won't cheat. And then a teacher comes and is like, Aditi cheated, but my previous teacher knows that I don't cheat. So she, in a different condition, understood, right, that this Aditi has a principle and she does not cheat. So I will give her the benefit of doubt. So in a new condition, she used my previous principle to trust on me. Similarly, in science, we have the same. It's a general rule or idea, okay, that helps us understand the science and apply it in a new conditions as well. Just like my teacher understood me and applied it in a new condition where there were so many fingers pointing out at me. Okay, so the principle of conservation of energy also applies. One example is, my friend, so if I eat food and I slap my brother, okay, and if I don't eat food for 10 days and then slap my brother, which of me will have more force? Don't slap your brothers. My brother is not slappable. He is actually, I don't know. Okay, so if I have eaten so much food, I have so much energy, I'll slap him with a bigger force. Right? If I didn't eat for 10 days, I'll slap him with a little less force. Okay. How? Because the energy from food is converted into muscular energy. Right? So I can, with my big muscles, I can slap anyone with a bigger force. None. That's the case. Now, next we have, these are all laws, theories and principles. Let's just quickly summarize them. So, laws is what is happening, okay? What exactly is happening, like Newton's laws of motion, right? F equals to ma, that force is equal to mass into acceleration. So, this is what is happening, right? Then, this is, of course, example is Newton's law. Then, theory. Why is it happening? Why force is equal to mass into acceleration? We did so many experiments and we know that with the mass, if there is a heavier mass, a truck is very hard to push than a car, right? So we did so many experiments and we say it is happening because of the mass, because of the change in acceleration, because of the temperature and pressures around us, correct? Then principle. Principle is like conservation of energy. I know that the food I ate converted into chemical energy into my body, and that gave me enough strength to slap my enemy, and so that chemical energy got converted into muscular energy. Great. Okay, very good. Now moving on to the very good thing. See, I'll tell you about a scientist. There was this scientist, Meghnad Saha. Okay, he got his photo on Indian's stamp, right? Indian postage stamp. Why exactly? Why? Because he studied stars and he simplified those stars. What are you trying to say? See, think of like this. We often say science often begins by ignoring the details, not looking at the details. See very carefully. Not looking at the details, but ignoring some details. Okay. So what Meghnad Sahaji did, he was studying the light coming from the stars. Okay. So when the light was coming from the stars, the stars are so big. So lots of things can be happening inside them. The energy of the star, the atomic structure of the star, the reactions happening inside the stars, right? Or every movement of that star when it's coming closer, it's going away. That's all the things that were happening, right? But he ignored everything. He ignored literally everything and he saw just one simple thing. He ignored all these complex processes and he saw that this every moment, see, look at this very carefully. He did not try to model everything, okay? He did not try to model every single atom. He did not try to model every single reaction or every moment of star. Instead, he treated the matter. The star is formed with the matter. Inside the star, he treated that matter as a hot gas. So he said that this star is not just a rock, it's just a gas. Okay, and then he studied, so instead of leaving all those atoms, he studied this star just as a gas, just as a hot gas, and ignored all the complex processes and focused only on its temperature and pressure. Every reaction, every atom molecule he left aside and he focused on the temperature and pressure and how these atoms are formed from the ions, right? So he simplified it. He simplified the procedure just like we studied model, right? The complex structure is simplified. Similarly, Meghnad Sahaji simplified the structure of this complex star and thus he explained that the color of the star, see, listen very carefully, pay attention. The color of the star depends on its temperature. Of course, we know if something is very heat, the color will be a little bit orangish. If something is cool, the color is a little bit blue, right? So similarly, he said he incorporated the color and temperature and related them together, right? Ignoring all the chemical reactions and atoms and all those things happening inside the star, and hence he got his photo on Indian postage stamp. How good is that, right? Okay, now moving on, we have one very more interesting thing is our conversation between who we have, Meghna and Varsha. So there are two people. And Varsha says that it will rain this afternoon because the clouds look dark. Now you are Meghna. Okay. Now we studied that we have to ask right kind of questions. Right. Now what are the questions you can ask? You know, how do you know that it will rain? What if the clouds just skim over us and it doesn't even rain? So what is the wind speed, right? If the wind is very fast, the clouds may not rain, right? And they fly past over us. Correct? Thank you, everything. Okay, great, very interesting. Good. This chapter is actually very interesting. So what will you ask? What is the humidity? Right, so we know the water, the temperature, the humidity plays a big role in like rain, right? Whenever there is rain, the humidity in the temperature in the atmosphere increases. Correct. So you might ask, what was the humidity? And you might guess that if humidity is more, that means okay, it might rain. If the wind is less and the clouds are just approaching us very slowly, very carefully, then it might rain. Then they won't skim past through us. Right? What was the temperature when it was rained last time? So last time you are comparing the things last time. So you are guessing or you are predicting the weather, right? By using temperature, humidity and all the parameters. What was the sky look like when the last time is... Okay, your name is Keshav. Okay, Keshav, hi. Okay, what was the sky like when it rained last time, right? What is the humidity? Was it above 80%? What is the speed in the wind direction? Is the temperature dropping? If the temperature is keep on rising and the bloods are there, then it does not align with our basic conditioning. We all normally know that when it rains, it gets cool around us, right? So that's the basic understanding of us, correct? Now, you can predict if the weather is dropping, if there is humidity. How will you feel humidity? You don't have those things that can measure humidity. You can just look around us, right? You can see around in the temperature that if you feel humid, if you're sweating a lot, then there is so much humidity, right? Shanku, hello ma'am, do you still know me? Yes, of course, Shanku, I remember you. I remember you were one of the consistent students of our class, right? So I do remember all of my kids, don't worry. Okay, so we were talking about humidity. See what happens now, my hairs get like this, very frizzy when in humid. If you have seen Friends, you know that Monica's hair, like, it gets frizzy when it's humid, right? That one episode. So just like mine also get like this frizzy hairs when it rains. So I can clearly say that it's humid and it might rain. Hi Rasan, how are you? Hello everyone, how are you all doing? I think all of you are enjoying your summer vacations, right? In here the weather is really good, so I can say that it might rain. It's actually raining almost every day, right? So just by looking at my hairs you can tell that the weather is rainy. Okay, so those are some of the things, those are some of the questions that you can ask to what? Why do we have to ask these questions? To predict that it will rain or not, correct? To predict that it will rain or not. And then we go on to a very important point, that is predictions. What are predictions? What are predictions? Can anybody tell? Okay, so do I have that question here? Yes, here, prediction of a cricket match. So do you know, we are all I think very much aware about the IPL, right? So the Punjab Kings were performing very well in the starting, right? They were winning every match, and my father and my brother were like, they were like praying every day that please don't lose the match, please don't lose the match. And I was sitting and I was like, they will. Even though they will win all the matches, at the end they have to do something like this, something or the other, that they will lose the match. Either in the last over they won't be able to hit the bat, or in the last of the series they just go blind, or whatever is happening, and that happens. Thank you. My prediction was right. I'm not happy about it, but my prediction was right. So what was that? That was a prediction based on what? Based on my past experiences, based on the experience that I know my team very well, right? So that was the thing that was happening. I saw the last matches. I saw how all the match and the team is performing, and I predicted something. Okay. Ma'am, I am in 12th now and I will come on this channel last year not to study but for talk with my friends in Todd's class last year. That's very flattering, Shanku, but I still do remember now. Okay. Great. Very good. Okay. I was predicting the Punjab Kings downfall. Okay, and I predicted it right. How did I predict it right? Because of the past experiences of me with that team, correct? And that is how we land on predictions. Predictions is when our laws, when our theories, our models, right, they are well established and they allow us to anticipate what will happen under new or different conditions. Even though the team was performing right, the law said that Punjab Kings will go to the downfall, will have a downfall, and they will not perform well. Why did it happen? Because it's a theory I made, because it's the pattern I saw, because it's the model I saw in the past, right? So in the new condition, in a different condition, that is this series, IPL 2026, I predicted something. Just like we predict weather, right? Just like we predict motion of objects. Forecasting future events. Yes, Keshav. Yes, exactly. Forecasting future events like cyclones, like rain, like what you can say, a tsunami or something. By the way, I'm great, Shanku. How are you doing? I'm great, actually. Now I'm great. So, we predict weather, but be very careful when you forecast future events, not like a baba that RCB will win, or don't come at me, RCB can win, or the world will end in 2026, but it didn't, right? So you cannot forecast all the future events. You can forecast the events which had a pattern, which were associated with some law, with some theories, with some models, and hence by using science we can predict new theories, new different conditions, new outcomes for different conditions, right? All good. Great, Shanku. Today you don't have friends in your life, so you are just talking to me now. So, predictions of objects, if predictions matches our observation, science wins. If prediction does not matches our observation, we go on and we study the pattern again. Maybe sometimes we get a new pattern, maybe it's just a random guess. So not all the predictions will be true. The forecasting of events, the forecasting of weather will be true for some time only, right? For some time, for a day or two, that cyclone will hit in a week. That can be true, but you cannot just imagine that it will rain after 2 months on this day. You cannot be that predictable, right? Because the rain depends on lots of things. The rain depends on temperature, it depends on humidity, it depends on pressure and all those things. Even the minor changes in like Bay of Bengal can like deflect the changes in here in Bangalore as well, in Punjab as well, correct? Ma'am, you expose that you... No, I'm not RCB hater. I love Virat Kohli. No. don't say that. Calculated tukka. Yes, you can say that. Calculated tukka also. Predictions can be. But we in science like to name these fascinating things, that is predictions. Not merely a science word, but we use science to predict the future things as well. You know, you see machine learning models as well, right? We train a model and now on the basis of this training, we know that this model will work, right? Will work according to the data set I gave it in the past. So what we are doing? We are training it and it will now predict that what can happen in the future based on the previous events. Right? Like the monsoon season in India. What do you think it is? A lot of times due to the due to the climate change, our monsoon season keeps on changing. Sometimes it rains a lot, sometimes it doesn't rain. So we still make predictions, right? That June and July are going to be very heavily monsoon seasons. But sometimes it doesn't rain, sometimes it does. Although that is due to that is due to climate change. But we did make a prediction that today it's going to rain. Now it might not rain, might rain. So we use science, we use machine learning models, we use all these AI stuff today, but we used to do it with hand, with continuous and discrete mathematics in the early days as well. Okay, Shanku, you stop smiling. I'm not a RCB hater. Okay, moving on, we have a very, very cool question. Now, when I read this question in the NCERT, I was like, what exactly is this question? Why exactly we are doing this question? So, let's do this question and then understand, okay? Why we are doing this question. We'll do and then understand why we are exactly doing this question. Okay, read the question carefully. Read the question very carefully. The question says that estimate how many liters of air you breathe in. How many liters of air? Now, bacha, every time I told you to write given and to find and the solution. Now, even though it does not classify as a proper numerical, but it does have some calculation, it does have some things we have to talk about. But even though this does not fit in our criteria of numerical or questions, we will still go by our single hand, this structure of numericals, okay? आगे से will assume climate when you say yes. Thank you, Keshav. That will be good. Actually, I'm preparing, I think, chemical reactions and equations chapter for class 10 students. So I had that in my mind. That was the case, I think. Okay, great. Now, you've read the question completely. Estimate how many liters of air you breathe in one day. We have to estimate how many liters of air. Liters of air we breathe. Let me write it a little bit chotu. Yes. How many liters of, where is it? Yes. Liters of air we breathe in one day. That's what we have to calculate. Okay, that's what we have to calculate. Now, how can you calculate this? And they're also saying that start by estimating how many breaths you take per minute and the volume of one breath. Okay, that's one way to go. So how many breaths do you think you take in 1 minute? So roughly we take 12 to 15 breaths. 12 to 15 breaths in a minute. While we are resting. Of course, if you just came back from a run, you won't be taking 12 to 15 breaths in 1 minute, right? It will be much more than that. Razashi, how should I call you? Hi Razashi, how are you? 12 to 15 somewhere breaths in a minute. Very good. Now, how many minutes are there in one day? Can you calculate that? There are roughly there are 60 minutes and there are 24 hours. So total minutes in one day are what? 1440 minutes per day. We have 1440 minutes in a day. Correct? That's correct. Now moving on to multiplying this. So how many breaths we take in one day? This is 1 minute. This is total minutes in a day. So how many breaths we take? We take somewhere around 12 to 15. Not 12 to 15. 20 to 22,000. We take around 18 to 22,000 breaths in a day. 22,000 breaths in a day. How crazy is that? Right? Let's average it out to 20,000. Okay, 20,000 breaths in a day we take. And how do we calculate the volume of breath? See, I know it can be a little complicated. What we are doing, we are just estimating that we take 12 to 15 breaths in a single day, in a single minute. So 12 to 15 breaths in a single minute. Inhale, exhale, 12 to 15 times, right, in a minute. Now there are 60 minutes and 24 hours in a day. That means 1440 minutes per day. Correct. That means if you multiply these two, we take 18 to 22,000 breaths in one single day. Crazy. Crazy kiya re? Okay. Then how much liters of air we breathe? Because that is what we have. We have total minutes. Now if I calculate how much liter of air I breathe in one breath, then I will just multiply with 20,000 and I'll get the answer. But how will I do that? Let's imagine there is a balloon, right? There is a balloon and you at least take 3 to 4 breaths to fill that whole balloon, right? You take 3 to 4 breaths to fill that whole balloon. Correct. And that balloon, let's say 4 to 5 or 3 to 4, depending on your own capacities, right? That balloon, see carefully. There we have a balloon. Now, typically a balloon is of 2 liters of, it has 2 liters of capacity in it. Now, if I fill it in 4 breaths, that means I take 0.5 liter of liter of air in one single breath. 0.5 liter of air in one single breath. And hence, I got the answer. How, ma'am? In one day, I breathe 20,000 times. And in one breath, I take 0.5 liters. So, I'll just multiply these two. I'll multiply 0.5 liters into 20,000 breaths in a day. right? And that will come out to be 10,000 liters of air, and that is what we breathe in a single day. Understood? Now beta, this is just an estimate. This is just a prediction that we do 10,000 liters of air. We breathe 10,000 of liters of air in a day. Ma'am, what's your second favorite? CSK. CSK will be my CSK was, I'll say. Right now, I'm not completely sure. I'm not that much. But let's say CSK because Thala is constant. Okay, done. You are here just to ask me IPL. Okay, let me teach a little bit. I'll give you the answer as well. But okay, done. So 10,000 liters of air we breathe in a one single day. That is our prediction. But how do we know that it is correct? How do we know that it is correct? Okay, we can do one more thing. Let's just compare it with something that will give us a little bit more estimate. Okay. Now, what will we do in 1 minute? Let's say we talked about balloons, right? In 1 minute, how many balloons can you fill? 2, 3, 4, 5. How many balloons can you fill in 1 minute? Let's just say that you can fill 3 balloons in 1 minute, right? 3 balloons in 1 minute, and each balloon is of 2 liters, right? 2 liters. And there are 1440 minutes in a day, correct? So we multiply all these to 1440. What will this come? 2880 into 3, and that will come out to be 0.2462. 8640 liters. Now see, the actual answer is 8640, not the actual answer. Both are actually predicted. So this is 10,000. So we used two methods to see how much air we breathe in 1 day. One says 8640 liters, one say 10,000 liters. Almost equal. 10,000 liter per person and 11 players, 11,000 liters of air, 1,10,000 liters of air every day, and Punjab still couldn't qualify. That is funny. I feel like crying. I predicted that they will fail, but I still had a small hope in my heart that something might change, something might go different. But what can we do, beta? There is nothing we can do. We can't go on the field and play. Then Punjab will definitely lose. If I go on the field and play, then Punjab will definitely lose. Okay, done. So this is how we predict, and it won't be same every time. We used balloons. We can use something as well the next time. We can take help of something other than balloons, right? So we can move on to the next thing, that is how much rice would feed a family of 4 for a month. What is this? This is your science class, bacha, 9th class, 9th science. Debayan Brahmachari. Hello, Debayan. Should I call you Debayan? Okay, Debayan. How much rice do you eat in 1 day? Do you eat rice? I eat rice a lot. My roommate is fed up with me that I eat so much rice. Okay. But how much rice would a family of 4 needs for a month? How will you estimate them? Okay, now I want this is a homework for you. Okay, this is like a very interesting homework. I'll give you a hint. Okay, this is the hint, bacha. Look at the hint very carefully. Now what you have to do, for a normal adult we need around 2000 to 2500 kilocalories in a day to function properly. If you are losing weight, then a little bit less. Okay. Yeah. Hey Bhagwan. Great. Good dad joke. Everything. Keshav. Nice dad joke. Debian, do you answer? Do you mind answering? Okay. Now, what is the hint? As that we as a person need 2000 to 2500 kilocalories in a day. And how much much calories of rice has, how much calories, or let's just estimate a very filthy guess, 100 grams of rice. 100 grams of rice. How much kilocalories are there in 100 grams of cooked rice? Cooked rice. How much calories are there? You have to find it out, okay? How many calories are there in 100 gram of rice? You have to find that, right? And then we need 2000 to 2500 for one person. For one person. That means that we need 10,000 or 8,000 to 10,000 kilocalories for 4 people, right? For 4 people. Correct. So how much rice, if 100 grams of rice, let's say have 100 kilocalories. 100 kilocalories. So I'll just divide these two. 10,000 by 100. We get 1,000. That means 1,000 gram of rice a family will need to survive for a month. Still, that is bad. Like, that is not true. That's just 1 kg of rice. Did I do something wrong? 100. Okay, 100 grams cooked rice, 100 kilocalories. 100 kilocalories. We had to multiply this. Oh shit. Okay. So, in 100 grams, we have 100 kilocalories, and a person needs 10,000 kilocalories in a day. So, okay, that answer was correct actually. So, we need 1,000 grams of rice every single day. Every single day. That means 30,000 grams. That means 30 kg of rice can feed a 30 kg of rice can feed a family of 4. Now, it's not the right answer. I just guessed that they need that there are 100 kilocalories in 100 gram of rice. You search it out. What is the kilocalories in 100 gram of rice, and then multiply it with all other things we did, just like we did here. Okay. Okay. Next, let's move on to a very important thing is, beta, science is connected. You see, you in after 10th, you will go into +1 and +2. They're like, I don't like bio, let me just take maths. Okay, I don't like math, let me just take bio, or let me just leave science overall and I'll take commerce. Okay, still you have math. Now, all this is made for us to understand, right? For us to organize and characterize our interests better. But actually, science is literally connected. Let's say these are the masks we use in during COVID-19, right? During COVID, we all used masks, right? Now, in the mask, do you think a physicist made this mask? Or a chemist made this mask? Or a mathematician made this mask? Or a biologist made this mask? Who made this mask? Everyone collectively came together and made this mask. They sat together, had a round table conference, and they made this mask, right? Why? Because the particle size that the corona particle should not enter in the mask, right? Who will decide that what will be the size of the particle? Maybe a physicist, right? Then moving on to chemicals, what kind of material the mask should be so as to block the coronavirus entering into the mask? A chemist will decide that. A biologist will say, no, we can use this material because the virus has these properties. Maybe it can penetrate the mask. So change the material of the mask. So chemist said, okay, this material, this works. Biologists say, yes, this works, right? Then physicist tests its particles. Okay, this works. Then a mathematician comes and is like, let me check the efficiency of this mask. So he goes, it's not efficient 100% of the time or 99% of the time. It's efficient only 20% of the time. So it's like, no, that's bad. The virus will penetrate. Let's just increase the efficiency. So again, they work on particle size, material, virus, efficiency, and it's just a whole cycle. Okay, and that is why we say that science is connected. Okay. I have a question for you. Now, how, okay, I forgot to erase this, but how all these things are connected? Okay, these are not the correct answers, these are wrong answers. Let me do it. Yes, these are not. You give me your answers. Okay, what is the mobile phone is also includes science, right? Engineers made mobile phones, right? What did they take in 11th and 12th? They took science, most probably. So what is the physics part of your mobile? What is the physics part of mobile? Where in mobile the physics is used, right? All of you before that, subscribe the channel, like this video, very good, fast, and then answer this question. Beta, we are coming live every single day. I am coming live with biology, chemistry, physics every week, okay, for 9th, for 10th as well, and we are doing all the questions. So we did so many questions here, okay, we did not so many, but because this chapter does not have so many questions, but if you go see our channel, we did 100 questions in one go. And you tell me, if you do 100 questions, will anyone defeat you? Can anyone defeat you in your boards? No, they can't. Okay, so subscribe the channel right now and like this video, everyone. Great. Okay, now answer me, in mobile phones, what is the physics part? In mobile phones, you hear sound waves coming out of the mobile. That is what? That is physics of it. That is sound waves coming out of the eye. The light coming out of the phone, right? Those are also light waves, right? Those are light rays coming out of the mobile, right? The electromagnetic waves, the EM waves coming out of the mobile phone. We say to keep it away while sleeping, right? Yes, screen and touch physics. Very good, Keshav. Yes, Shanku. What's your question? Which stream did you take in 12th? First, tell me that. What is your stream? Okay. Until then, let me just teach. Now, chemistry is calling. Okay, chemistry part of the of our phone is the batteries, the chemicals in the batteries, right? Our phone has batteries, right? Although when you go to a higher level, batteries incorporate with physics as well, because I told you guys, it's all connected, right? So batteries, but for now there are lithium ion batteries that are inside your phone, right? So all those are the chemistry part of it. What is the biology part of it? How your brain reacts to those videos, how your thumb, you know, there is this one, I also have this. So in this generation, new generation, because we use phone a lot and we like hold our phone like this while scrolling reels like this, right? So there is this dip on our pinky finger. There is this dip. I literally have this and I was so sad about it, but I have it. So this is the biology part of mobile phones, right? How it reacts with our brain, what are the chemicals it releases in our brains. In our brain, we have one brain. Okay, calling in mobile is also physics. Yeah, you can say that, but it comes under sound as well. Microphone, speaker, right? You can say that. Then that's the biology part of it. What is the mathematics part of it? All the data that it collects, it shows your time management, how it does, because there are so many devices in your mobile that actually collects that data and do some mathematics stuff on it, and it shows you what was the time, how much time you used, you scroll those reels, right? So this whole science is connected, beta. Anything you take out, everything is connected. In our body as well, we see I am wearing this chashma. It's your light chapter in class 10th, right? I am eating the food, that is biology. It's going through esophagus, my mouth, the whole digestive system. Then it goes into my stomach and there is HCl, the lining, the stomach lining. It protects it from the acid, right? So that is chemical part of it. Correct. And then I walk, I experience friction, that's physics part of it. Dopamine is released when we watch reels. Yes, exactly, Keshav. Everything, Keshav. Correct. That's good. So in The whole essence, the whole science is connected, beta, and that is what this chapter was about. Okay, now the next time we are going to come live, I am going to come live for the chapter chemical reactions. No, for you it was cell. Okay, the next chapter we will be coming live with is cell, the building block of life, and we'll study lots of good stuff about it. Okay, we'll do lots of questions and we'll prepare you for your class 9th. Okay, great. Shanku says arts. Oh, great, Shanku, great. You have arts. You have a little bit of good interest in arts, right? Now, I promised all of you to give you a strategic insight on how to study science for whoever stayed till the last, right? Now, this is very important. Listen carefully, okay? Now, for chemistry, I know you guys know a lot of people give you advice on how to study, what to study, but this is exactly what to study, okay? In chemistry, first go through the concepts. Ma'am, how? I have one shots uploaded, go watch them, and below that there is a PDF link. Download that and study from there and revise and clear all your concepts. Okay, genuinely didn't realize when the last hour passed. Oh, that's great. I'll take that as a compliment, right? Now, so do the concepts first. Very, very important. Concepts is everything. If you don't, it was interesting. Thank you, everything. I do try to make all the lectures interesting, and I have put so many lectures on the channel, so you can go watch that. All of them are interesting, beta. Okay, so what was I saying? I was saying that concepts are very important. If you don't understand, you don't have to hurry and rush to the next concept. Sit there and study the concept. Okay, you don't have to worry that I don't get it. I feel like a dumb person because I did that, and that's not good. Every person around you right now is literally as dumb in science, because that's how we are supposed to be. Okay, we are all supposed to be unaware of science, and that's how we studied, bacha. That's how we study. Okay, so clear your concepts first. Now the main part. There will be so many equations, right? How do you practice writing? Bacha, if you are here to for me to tell you that there is some smart trick you can follow, then now is not the time. Okay, you come at the end of the year, you come before the examination, I'll give you tricks, I'll give you smart tips to work smartly. But right now you have to practice. Right now you have to practice and practice only. Okay, next live will be on Friday or Saturday. Friday, everything. Next live will be on Friday, and it will be of the chapter cell. Okay, very good. Now, numerical. We have numerical. In the numericals, I told you the proper pattern, right? How to do the numericals. First, write the given, write the to find, write the solution. It will, trust me, it will make your numericals 50% better. Rest is your hard work, but the 50% of your numericals are just based on the structure, beta. Okay, now back to the tips. What are the tips? Do concepts in chemistry, equations, practice them. Very important, practice them. I put a video where you can practice writing chemical formulas, so you can see that as well. Okay, Ritu, hi Ritu, how are you? You have just came in the perfect time. I was giving the right strategy, a small strategy for you to ace your 9th class, correct? For in the ACE series. Done. Then numericals, do not forget the units and activities. Bacha, activities are very, very important in your board class as well. That is your 10th class, right? Lots of questions they ask just from the activities. So make sure you are reading those activities very carefully. I will include them in my one-shots, in my live sessions as well. Do not worry, but go through them by yourself as well. Okay. Then moving on to biology. What you have to do when you write something, when you learn, there is so much theory in the biology, right? So in biology, you first learn the structure and the function, and then you learn them together. And then the theory, or already you will know the theory if you know the structure. And that's how the beauty of visualization, the beauty of studying as well, right? Hi Sparkle, how are you? Anu, hi Anu. Hi Ritu, hello everyone. You all have just come on literally the best time. Okay, this is the secret strategy I'm giving all of the people who are in the life. Okay, so structure and function we have to learn together, not alone. Okay, not differently. Mix them, understand the structure, and the theory will come to you eventually automatically. Okay, then flow charts, very, very important for you to understand, for you to present your questions. Okay, done. Next we have keywords. Now in biology, actually in chemistry and physics as well, keywords are very important. But in biology, the keywords are like literally a ramban. Okay, what are all these emojis, you people? Why are you looking at each other like that? Okay, so in biology, keywords are very important, so focus on that. Okay, then in physics, now in physics, see, concepts are of course they are important, ma'am, we know. But the diagrams and the graphs, this will change your game. If you know diagrams, if you know what graphs, how graphs look like, if you understand how graphs are made, then better, no one can beat you in science, especially in physics. Okay, if you know, like we studied masters, right? So even then we were using graphs. And what graphs? These velocity time graphs, distance time graphs we were using. Okay, so those are very important for you. And then numericals, again the structure I told you, right? Just do the calculation, practice the calculation, and units are very, very important, my friend. And the final advice, relate science to everyday life. My teacher used to say, do you think oxygen flying around in the air? I'm like, no, I'm not mad. But he was like, you will see in few days. So I'm going to tell you that because it's just a different world around us when we see, when we look it through science perspective. Correct? When you look that there is nitrogen, oxygen, so many compounds in this atmosphere, you just feel like you know something a little bit more than rest of the people who are unaware about the science. Correct? So that was it for this live session. But first chapter is done in the live session. Motion chapter as well as motion chapter is uploaded, and very soon this exploring chapter is also uploaded. The one shot is uploaded, and very soon you will get your second chapter, the first chapter, that is cell as well. Done. Okay, so entering the world of secondary science is done. Also, just letting you know, class 9th and 10th full series are available on our channel. We are going to come live. We are uploading one shots, important topics, important questions, NCERT questions, everything you can ask for. Okay, with the activities then for completely free. Okay. Okay, Shanku, great, very good. So proud of you. You've got an internship of automotive subject in 12th. That is really good. Okay, see, that is how you live in the world. You strive for better. Okay, just like Shanku. So that was it for this live, everyone. Subscribe the channel, like this session if you love the video, if you love the content, and I'll meet you in the next live. Tata, bye bye.